Are we good now? Not even. Okay, now let's see. Are we streaming to everywhere? Error. YouTube not receiving enough video to maintain smooth stream. Yeah. My internet connection sucks recently. I'm not sure why. It might be super laggy. Is it super laggy? Alright, Kick, shouldn't you be also doing this? Let's go. Let's go. I'm offline? I'm not offline. Oh, probably because I need to start streaming to Kick. There you go. Twitch. How about you? I'm sure which one is playing. Let's try that. I'm sorry, I know that the freaking internet probably sucks right now. I should do a speed test. They're gonna be atrocious. Let's do a speed test. Oh my goodness, it's crazy bad. What the hell's going on? Why's my Ethernet so unstable? Do I need to change out the plug or something? Holy crap. It is bad. Upload 7 megabytes. What's going on, bro? What's going on? I guess I should get my internet fixed before streaming. It's crazy. How bad is that? Alright, well, anyway. At some point, I'll fix that. I'm just gonna start replacing everything. Let's just check the network. Ooh. Ethernet cable unplugged. The Ethernet 5. Okay, whatever. Anyway, let's get to the video for today. Freeze. We're making a badge holder. Now, okay, that's something that you guys are probably not gonna have to do a lot, but of at all probably. But they want to do it. It's for a friend, so I must. So let's go ahead and do it. Opening Blender. Got some stuff down already. Nice and laggy. Okay, wow. I'm gonna go to items. Gonna go to. I'm going to measure this thing. Looks like we might have to divide this in two, so 48. $84. I'm dyslexic, okay? 84 divided by 2. 42. Gonna do at least 42. So let's try putting 42. The way I'm gonna try to design this, what the deuce? The way I'm gonna try to design this in Blender. What the? I want this thing to be facing me like that. I need this thing wide. 61. So it's about 30.5. 30.5. Now is that the whole thing? I think it's the whole thing, yeah. So it goes just to 61. Yep. The Z we said 84. The thickness we're gonna go to. My friend was mentioning he needs it to be the same thickness. That's about 3 millimeters. Freeze! It's so cool. Looking at an actual badge. It's hard and heavy. That's fun. Also got some handcuffs. So if you bother me, I'm gonna arrest you. I can do that, right? Alright, so thickness then. That's gonna be the Y direction. It's gonna be 3. And I like to have this thing facing me. For anyone who says that Blender is not precision, like CAD, AutoCAD or whatever, we're gonna prove them wrong. Watch this. I don't know what to do next. Alright, let's do... At the bottom, we're gonna actually add a name. You know, we're gonna add a name. And I wanna know the name. So let's, we're gonna use my name. It's not like I'm about to tell you who my police officer friend is. Zoom in. So rotate around the X by 90. Maybe I turn on screencast keys for those of you who want to cheat off of me. You bunch of cheaters. Alright, so let's tab this out. We're gonna do Garcia. Up. Usually I'm making prosthetics in Blender, but today, how do you center this? You know what you could probably do? You can probably go to set origin to geometry, which is the center, I think. And then snap selection to cursor. There you go. There. See? Don't tell me you can't use Blender like in an accurate way. People be freaking dumping on Blender because they're butthurt that they can't use it and they have to use their CAD. Okay, yeah. I feel like CAD's easy compared to this. But when I'm working with organic shapes a lot, because I'm doing prosthetic. I'm doing people who are amputees. So I'm scanning. I'm taking scans. I'm getting scans of people. And it's just easier. It's just easier. It's easier in Blender. Blender is like more organic. But you can totally use it for this accurate stuff too. What am I doing? I'm so distracted. You guys are distracting me. Alright. I could change the font too. I can change the size. Rotate around. In fact, I don't even know why I'm doing this. I should be just hitting this and hitting enter here. And what should my badge number be, huh? Let's make a badge number. Should we do just 7777? That's my badge number. Obviously, I'm just kidding. Shut up. Can I can put some spaces to center it, but is that really all that good? That's fine. It's fine. It don't matter. All right. There's my badge and my badge number. I think the first thing I'm gonna do next, we've got some requirements. We need to put a pen on this thing. We need to put some cuff keys. And I need to bevel these edges. And I also need to extend this. We're gonna extend this. Extend this right around there. Because this is gonna be 3D printable. Now. Okay. See, I got some cuffs to arrest you, so you better subscribe. You hear me? Okay. We've got some keys. We've got some. We're gonna use these as reference. Yeah, go ahead. Okay, we want to put a pen on this sucker so that I can write down your crimes. This is a cool pen. You can take it apart and put it on the back. Use it like a pen. That's pretty cool. It bends a little bit, but that works. They also said that they just use the top, the pen portion. So we don't necessarily need to account for both, but I'm definitely going to account for both because we're going to... You never know. Yeah, people have their own preference. So when you're designing stuff, you know, you make stuff with the most usability in mind. All right, so let's go ahead and we're gonna try to do both of these suckers. You gotta figure out how to grab these guys. Let's see what size of these. These keys are two different sizes, so we need to make sure. We need to find where we can grab these things. This thing is a 30.5. 3.5 shaft, but we can't really use that because it's got a key. 6.3. 6.8. Really, this the smaller one is actually bigger. It's actually wider. 6.75. 6.2. I don't know, that might be in the range we could use. 7.9 mid shaft. 7.9 mid shaft. Okay. So actually, that mid shaft is also the same size. 8.4. 8.4. Okay, I know. I think we're good. We just need to figure out where to put these guys. Because we're gonna want them to go in. Gonna be flush at the. Wanted it to be flush at the top. Wanted to kind of be flush at the top. With the ring though, we might take the difference. We could have this thing poking up on the top of the badge, but not too much. Alright, let's measure the length of our keys here. We've got one key that's 110. We've got our other key that's 80. 110 and 80. 110 and 80. Someone please remember that. 110. And 80. And this pen is going to be on this side. If we add this lanyard thing though, if we add this bulkiness, it's 120. So we could actually have it like that, and I don't think it should be much of an issue. As long as this one $62mm down is where we have. Where's my chat thing? $62mm down. Pro tip, we're just going to make a loop cut here. We're going to measure show segment. Okay. That's not right. Ah, it's because we're in meters. Dirt. Millimeters. Okay. How do I get this thing to give me some room here? No, I guess it can't. Text rotation in degrees. Not sure what that means. Oh. Cool. Okay, what was I saying? 62 or something? I'm pretty sure there's a way to do constraints in this program too. For all you CAD obsessed fools, 62. Alright, so now all I gotta do, grab these guys and bring it up to 62. It's like right there. And where do we have the major point of contact? Contact. Come on, key. It's got to be above 50. Got to be above 50. Gotta be above there. I need my cutoff right around here somewhere. And that means on this key, we're talking 21 millimeters exposed. That means 21 millimeters where you're gonna do your gripping. It's good. Plus you got the chain. All right, we're good. We are good. There's only problem with these measurements. They don't go with you. All right. Now I need to make these into the right diameter. And said diameter let's check it. Check it out. Long one. Long key. These are real cuff keys. I should not be showing you how to design these. I should not be showing you how to design keys for cuffs. That could get me in trouble, probably. 22.4. Okay, I'm gonna do this in a way where I'm not gonna get in trouble. 22.4 here. Was that what I said? Yeah. Call it 22.5. We're gonna need some extra room. So Let's do that. Now we're going to choose this vertex, or we can choose a segment. Just measure that segment. Oop. Yeah, no, we're good, we're good. All right, we're gonna bring this down to 22.5 there. Yeah, that's what we'll do. All right, now the small key. Oh, these are both tapered. They're both tapered, but they're not tapered. These don't look as 6.8, 6.2, right? So these things are not the same. But up here, 7.87, 7.86, 8.5, 8.5, just about. All right, so I gotta grab up here and up there. Luckily, those are the same. Good. Good, good, good. So then the keys. The keys 5.5 lock tumbler. Okay, but how high is it? I'm gonna say 4. I'm gonna say 4. I could, you could either actually measure this or measure to the thing, but you can see how close I am. So it's fine. I could bring it down more and get it exact. Not really. Most things don't actually require a massive amount of tolerance, In fact, machines and gears themselves don't require that much tolerance. Why am I getting... What is this thing in the background here? What is this? Oh, did I duplicate this? Oh, no. I'm just looking at it from a different angle. Yeah, okay, we're good. Okay, so... Really, only 2 millimeters? Let's just say 2.5. 2.5. What the... Why are these at an angle? That is so strange. Yeah, that's still strange. We can always measure again. I do, so I'm working on a badge holder. I don't know if you're still here. Ah, badge. Badge holder for cops. Or, you know, badges that have the same kind of geometry to it. And we have cop keys. Put on my face so you can see. Cop keys that we need to do. Also, I need to do stuff for cuffs. Designing stuff for cuffs. Maybe I should try to do this project cuffed, huh? You gotta like the sound of cuffs. Alright. Yoink. Yikes. They are heavier than I imagined. That's pretty heavy. I should try to do things cuffed, right? Could I do it cuffed? I'd have to move my arms around like that. Let's not give that a try. Maybe I could wear it around one hand, but anyway. Back to short. Let's figure out how to measure this stuff properly. In fact, let's just go to solid mode. And I want an overall length. What's 62 millimeters down, huh? Was that just the... Was that an error? Or was that the end of the road for me? That's the end of the clip. This looks like it's... Let's see, bottom to top, is that 18? .4. .4. But they're not both that size. They are not. I need to make one kind of generic key that'll fit both types of profiles. I think that's the deal. So what I said 22.4. If I made that too short, it's fine because I'll make it long. 22. Ah, okay. Can I label these? I feel like I should be able to label these. Okay. I'm gonna say this one is top to clip. Wouldn't that be clip to shaft to key shaft? Yes. Okay. Yeah. I'm gonna get rid of that one. And this one is gonna be, I don't know what it's called, but I'm gonna just call it a tumbler. $18.5. That'll be from shaft to top of tumbler, right? Yeah. Shaft, right? Shaft, which level shaft is this? 1, 2. We'll call this small shaft, thin shaft, narrow shaft. There's technically 3 shafts, top to bottom. We'll call this shaft 2. Shaft 2 to tumbler. Okay. This one will just be tumbler to end. Okay. Gotta label our stuff here. And then overall, I want to get an overall measurement. Overall. $110. Perfect. Large key, L key, key line pi. All right. Now the weird part is what happens if I hide this and I extrude this and I scale this like so, and then I unhide this it's at an angle. Why must you take the new one? No, make no sense. No sense make you. Why you do this to me? I guess the way around that would just be to make a different object entirely. That's so weird. Why don't it just stay? Like if I got you, Tumblr to end. On top of that, why the heck is it like that now? Okay, I see why people don't use Blender for modeling high specific stuff, high accuracy stuff. I get it, okay? But I don't care. I'm going to work around you. Alright. I'm just gonna work around you. I do not care. I could combine this stuff later. How good is that combination? Curious. Just curious. What's the best way to do this? Look at all these measurements, darn it. I guess we just kind of like screw it. Let's screw it. We're doing this the old-fashioned way. All right. I really want it to work. Why did it do that now? This is a 0mm. What's with this shit? Oh, which one is this? Why is this? Where's the 0 till? I don't understand that. Is there like a tiny segment here? That's awesome. Oh, there is. Well, which one are you now? That one. Okay. Well, you know, we'll try it this way. We'll try it this way, and we'll see how it goes. How do we get a reliable center mark now? What? Why you hate me so much? What to do? I think he made. Okay. Okie dokie. Yes, you. Measure you, please. 2.51. Uh, 2.51. But I don't like how that showed up. How can we do this so that it shows up on the edge? So I know that's the edge. I do that maybe. That's better, I guess. Gosh, it is. Okay, it takes a little finagling. All right. As I were measuring the tumbler to 2. We call 2.5. Ooh, that's from the edge of the shaft too. That's not actually from the middle. Hello. Welcome home. I should see the stupid print failed. Sweet, this print has me messed up. I'm trying to print the same thing for 4 days straight. It never has to fail on me so much. You see? This is not as fast. If I join these, what happens? Upstairs. Upstairs. Of course. about Voltron? Can I do a union with Voltron? It says new. Non-destructive union? Come on, even manifold. What? It buzzed. What the deuce was that? Okay. What the deuce is that? What's going on? Merge, I said. Voltron? How's you do union? Measurements get effed up. This stuff gets effed up. My whole life gets effed up. Non-destructive union. Oh, of course it's non-destructive union, so it's non-destructive union. So you can move it around. That's the same as just like exporting all the stuff separately. So let's just go back and do this old-fashioned way. Alright, let's delete that. Let's just take this, make sure it's manifold. Oh, my printer just failed. Great. Filament stuck. Let me go try to fix that. print a PCL like orthofilament, as I mentioned earlier. But one major problem has been lifting off the bed. The bed temperature is 45 degrees Celsius. How can I address this? It's not very low. It can actually be 45 degrees Celsius bed can actually be too warm for good grip, depending on the plate and cooling. Here are the fixes. Lower the bed temperature. Counterintuitive but important. PCL softens easily. If the bed is too warm, the first layer stays rubbery and gets dragged by the nozzle, which causes lifting. If you're on 45, not try 35. Any orthotic lab prints actually print PCL on room temperature beds with adhesive. Huh? PCL sticks much better when the light adhesive layer, best option. PVA glue, very common for them. Really? Bed adhesion problems are often Z-offset related. Slow the first layer. Turn off fan for first layer. Try 0 fan for first 3 layers, then 20 to 30% max. Typical PCL setup bed 30 to 40. Really? You just told me earlier that the PVA glue stick is what was causing the problem with lifting. PVA glue can either help or hurt depending on what failure mode you're seeing with PCL. Clarifying PCL orthotic there are 2 complete different necklace. Bed adhesive to the plastic never sticks well. I just lifted early. And slide around so it doesn't look flattened. In this case, PVA glue helps stick anchor surface area. Grip. The first layer dragging. Very common. First layer prints fine. The nozzle catches the plastic, pulls it out. Plastic looks rubbery or smeared. You see buildup around the nozzle. In this case, glue stick can make it worse, but because PCL is soft, the longer the nozzle drags the interior, the glue layer allows the whole sheet to peel instead of shear. We talked about prints clumping with the nozzle deforming. Sounds like failure mode 2, which you are removing for your specific situation based on your earlier choice. You describe element depressing where the extruder grips clumping the nozzle. I strongly suggest heat creep. thin bar, very slow. Not strong suggests yes. Plus soft first layers, not. If we said, oh, I'll try this print without the first clean. 35 to 40. 0 at first 2 layers. My gosh, I've had so many failures with this print, dude. So let's just update the printing profile a little bit. We'll continue modeling in Blender. Figured it would stick better at a hotter temperature. Minimum fan speed, layer time, huh? Layer time. The part cooling fan will run at the minimum fan speed. And estimated. First layer. 0. Let's do first. It said first 3, now it says first 2. Three or 2, which is it, dude? Let's see, this first 2 layers done. It also looks like the walls aren't connected to the solid infill layers. How do I fix that? Question mark. Classic wall to infill one. Increase infill overlap. How such is the infill perimeter overlap? Wall infill overlap. This controls how much infill touches the wall. Thanks to advanced overlap. Windows fine? Search for overlap. Excuse me, I'm yawning so much because I went to sleep at like 3 a.m. last night. Again. Alright, let me see. We'll go up here. Check first layer wall and wall settings. Your walls are thin and the info wide, side to side gap. All calc. I have like 6. Excuse me. Fudge. Search for overlap. Infill wall overlap. Infill wall overlap. Increase to 25. Alright, while we wait for this print to undoubtedly fail, I really hope it doesn't, but my luck with this filament has not been good. This is a I don't even know if it's considered an exotic filament. It doesn't feel like an exotic filament. It just has a really low melting point. I'm using ortho filament so that we can remold stuff. You know, so basically, you can't see. Basically, we're going from this. We're going from this, from this. I'm going from this to this. Okay, so we're printing this thing flat, and you put this in hot water. It's like barely warm. Hello. Hi. Hi there. So you're taking this. We're taking this. We're taking this thing. We're just putting it into some hot water. Some hot water. And then we wrap it around our hands. We wrap it around our hands. Or your patient's hand, right? And it can conform to this. And this is pretty rigid. Right? And then what we do is you stick your hand in here. Tighten some Velcro. Built-in loops. And there. You got a hand brace. And it feels pretty comfy. Like, it's not too bad. It would benefit from having maybe some sort of liner on the inside, and so you could basically put a sock on and cut a thumb hole and finger holes. When we get socks, we just get like these tubular socks that are open on both ends, so really just cut like a thumb hole. And this is quite good. But I need to print this stuff, and I've been having the darnest time printing with this. It's been insanely difficult. I haven't got like necessarily clogs, but the filament gets soft at really low temperatures, and you can't push it too fast through the machine, or else it'll start grinding the filament. And when you deform that filament, it can no longer push. So it's like the filament's a little tube, and it's a little wire. And if you grind off too much on one side of it from trying to push too hard to the extruder, it just fails to grip. It fails to grip the filament going through. Right? It fails to grip the filament going through. And then you don't get any printing. It's not necessarily a clog, but it's a huge issue. And I think the same thing happens with like TPU. But I've printed TPU, and I printed TPUs that are softer. So this has been a serious challenge. I've wasted an entire kilogram, not entire kilogram, 500 grams, and just to have this filament shipped over to me is like $500. It's like $100. $500. It's $100. I should really do a video. I should really do a video on it, because I'm spending too much money on it for not having shot a video. Alright, anyway. We're gonna do this thing, and we're going to do it with my crappy measurements here. Alright, duplicate. Not the whole thing. Just this portion. On with measuring. Not duplicate, we're gonna extrude. Get this stupid freaking measuring things that are cockeyed. Get rid of them. You son of a... Okay. Okay. Alright, so... a show... I mean, you could print these things at a TPU. These wrist hand orthoses, orthotics, whatever. You could technically print them at a TPU and then like heat them up, but it's too hot. Too hot. So from this edge to this edge, you're talking 2.5. So I want that. So scale up 2.5. Mr. Fantastic. He's very fantastic. All right. Now this shaft is how big? Right, it's 2 millimeters. It's 2 millimeters. The shaft should actually be. Where's my light? I need my ring light probably, right? Wouldn't you guys agree? You probably can't see me that much. I don't know where that is. Is the ring light? Oh, I'm just dropping shit. Is it even here? Okay. That might be a little better. Just discovered something. Bouncing that light off the wall is actually much better. Much better on my eyes. Alright, let's measure this. .5. My stomach is gurgling. Why is it gurgling? Probably I drank all that coffee. People fight about it too. Just double check. A 1.7. 1.75. Okay. Chef de Mundo. Now, it's on the larger variation. That's on the larger variation. We'll deal with the weird stuff later. Now we're talking interlocking. .84. 6.36. Maybe we go 6.36 up here. The next segment. $11.66. 11.66. Loop cut. So, and then what did I say? Must be the smaller one. It's like 6.45, 6.4, 6.45. We'll do like 6.45. This stuff is gnarled. I'm really gonna want like 8.5 is the part that's gonna be gripping on the most. So what did I say? 6.32. 6.32. 6.4, call it. We'll just go to 6.8. 6.8 divided by 3.4. Now this does have a taper, but I don't think I'm gonna worry about the taper. Continuing up. The rest is gonna be 6.4. Yeah, rest is gonna be 6.4. 3.2. What? What? I'm sorry. 8.4. I'm not saying that'll make no sense. 8.4. So 4.2. It's the same length, right? Yep. Let's dissolve these right now. All right. Now, since we are creating a pocket that needs to adapt to both of these keys, gotta make this work for both of them. It's 3.4. Is this 3.4? Good. One problem is the length. Okay, where is this thing precisely? 7.8, call it. Go ahead and bring the bottom down a little bit too. Okay. That way, it'll cover both of these. Like that. Let's grab all of this. Great. Start creating our timeline. to get this key past here, because we definitely can't get past here into there. We'll have to extend this. Which is kind of interesting because that's larger than that, so that needs to go all the way up there. Alright, so let's just merge these vertices together. Merge that together. Wait. What did I just do? No. So the best place I can have this seat up is up here then? Probably. Let's try deleting this all. I don't know. Let's just take these, bring them up. There's ways to do this. No. Jeez. Fine. Huh? Now you snap? Edge perpendicular? Okay. Maybe that works. Just to be sure. Skill C, 0, enter. Now. Yeah, I don't know, because I feel like maybe Maybe it's better to... Maybe it's better to join these traditionally. Kind of did what I wanted, but it's got all this stuff here. There you go. All right. Well, that's all right. I'll deal with that. It's got all that work for that. I could have simplified this a lot. All that work for that. I feel like I wasted my time a little bit. I'm gonna move on to the pen. Pen's got a lot of flat sides to it. It shouldn't be too big of an issue though. And should I leave the bottom open so they can like push it out, pull it out? Something. $11.5. 11.5. I'll do 11.5. This one would be easy. No. There. Radius. I can't math, okay. I gotta check the printer. $5.75. There. Okay, I mean, it's still printing, but I don't have high hopes for it. I already failed this print like a couple dozen times already. It'd be cool to get that good to go though, because it's literally just like a assistive device for people who don't have fingers or who can't make full use of their fingers. So it'd be really cool to get that actually useful. All right, how tall do we make this? That's important. So like 50 millimeters. Maybe I can add this in OBS, huh? Let me see if I can do that. All right, now we can rage at this printer. We can check it out while we print. And watch it fail when it starts failing. Oh, there we go. Started to fail. Getting lift. Like, why? Why are we getting a lift? You know how many times I scrubbed that thing with alcohol? I don't know what to do about that. I gotta try to do something. I don't want that thing to fail. Alright, we're back. Okay, I give up. Ask AI. You really think that lowering the bed temperature to 30 will help the filament stick better to the PEI plate? I tried my best. This print is probably going to fail since that lift might cause the nozzle to slam into it and just pop it off the bed. It's definitely happened before. Might happen again. And I'm out of filament. I don't think I get more until tomorrow. And it sounds like it's dinner time. So I'm gonna go off to dinner. Yeah, I'm coming. Thanks for calling me. All right, let's just pray. Let's just pray, guys. Please pray for me. Hopefully that's going to work. My children are calling me to come eat dinner. So I'll catch you guys later. Thanks for showing up. You guys are awesome. Let me know if this 3D printer window was a good idea. You know, maybe it is, maybe it isn't. I can adjust it some. Can I? That's probably just returning. Oh yeah, that's just returning it. Alright. Alright, peace out, guys. Thanks for joining me. See you in the next one. It's still on.